welcome everyone. This is a this is a bit weird, but yeah, hopefully I get used to it. So light, it is something that is all around us. It brings us colors, shadows, and reflections. And yet, it's something that a lot of people don't know to the full extent how it works. I know I didn't. Sure, I've done some shaders and I knew kind of the basic math of it, but I didn't really know how to make use of it. And yet, I started as the generalist in the lighting team 9 months ago, and I was part of the massive refactoring of the light modes and the lighting explorer, which meant I sat in endless meetings where abbreviations GI, AO just flew over my head. I realized I was walking with giants, and being short and all, I was, busy not trying to get stepped on. As an engineer, I started hitting the books. I started reading up on everything, but it was just so much stuff. Then I had a breakthrough about 4 months ago because I had a few friends over at my place, and one of these guys he was actually the guy that hired me at Rovio, so a very senior guy that I very much look up to. And he came up to me with a beer in his hand, and he was just like, "I really hope this party goes on really late tonight." I'm like, "Why?" He's like, "I'm baking light maps at home, and I have no idea what I'm doing, so, I'm just hoping it's going to be done." And it kind of hit me that not even these people, that really senior Unity people, know how to do this stuff, and I wasn't alone. And maybe I was able to help him. So I was standing in between with the experts and the code base on one side, and the pain of the users fresh in my mind on the other. My name is Jennifer Nordwall, and today I'm hopefully going to teach you how to bake it till you make it. So, this talk comes in 4 chapters, basically. So first I'm going to touch on the basics, and then I'm going to bring up 3 key issues that a lot of people have. So I've been talking to our QA about these things. So it's mixed lighting, and then UVs and artifacts, and then also some tips and tricks how to speed up your bake. So, the basics. I don't know how many of you guys have been to a talk that it really seems cool, but then at first 5 minutes you're lost. You're like, "Oh, I don't understand any of this." So my idea here tonight is to kind of bring you all on the lighting boat before we take off to the more gnarly bits. And I'm also going to sit out and ask the experts afterwards. So if you have any questions regarding basic lighting, come up and talk to me. And also, Q&A at the end. How many of you have baked lights before? Okay. How many of you guys don't know what baked light is or how to use it? Okay. Yeah, we have a few people. So it's obviously not this thing, even though this can also blow up in your face if you bake it the wrong way. So if we look at this chair here, and what if I told you that the shadow below it wasn't actually real, that it was just me painting it on the ground? Would you have noticed? Yeah, obviously not. What if you were chased by brain-hungry zombies? You probably would not have noticed that this shadow wasn't really real. So perspective and light are essentially the 2 things that contribute to the illusion of 3D in games, and it gives so much beauty and the sensation of that it's real. But it's also very, very expensive, and some of the things I'm going to show you today you can't actually do real time. Just because it's just going to cost you the entire budget, and you can't just ship a game with just a light bulb in it. So what do I mean by that? In computer graphics, we kind of tend to split up light into 2 subcategories. So we have the direct light, which contributes to the specular and the shadows, which is probably what you think of first when you hear lighting. But then we also have the global illumination, which is all this nice indirect light So it's our like way of simulating actual light. So it bounces around, it brings that redness onto the outer sphere. So it's essentially the indirect light. So we have direct and indirect light. And global illumination, like currently you can't really do that fully real time because it's just very, very heavy. So we need to, I'm going to talk today about how you can kind of get that into your game by doing, yeah, a few hacks. So yeah, great. How do I actually get this into my game? The first thing you need to do is to kind of mark this object as static. And before you just, usually people just tick it up in the box there, but you kind of need to know that it's essentially just the third option there that we're really interested in. And you can also, from 5.6, you can also do it on the actual mesh renderer, so you can just mark there as lightmap static. And it's essentially the same thing. And what this means is that from a lightmap perspective, this object's not going to go anywhere. So that chair that I was talking about before, you know, it wouldn't make sense if we were going to paint that shadow on the ground and then when we're going to move that chair around, that's not going to look great. Then you go into the lighting settings, and if you feel that you don't recognize this menu, it's because we changed everything since 5.6. And we actually hired a UX designer to be able to make this more easy to use. So we're really, really making sure that that's gonna, yeah. And there's a lot of settings here, but the first one you kind of need to focus on is if you want real-time global illumination or baked. And some of you guys might think now, like, oh, she just told us that there's no such thing as real-time global illumination. And it's actually pre-computed real-time global illumination. And what this essentially does is that we pre-compute the relationships, so which objects bleed on what. So if I'm, example, standing in a room next to a red wall, that bleeding is going to be on me even though the light's going to change. So, and this allows us to kind of bake these light maps real time. So you can move the lights around, you can change the intensity, the color, and it's, you know, you get a really nice result, but it can also be very, very heavy. So it's not as lightweight as baked. And if you only take that one, you're going to end up with a lot less settings. So everything here is grayed out because we're not dealing with light maps anymore. So we're just going to have this indirect resolution, which kind of controls the resolution of that relationship, the clustering that I was talking about. And usually that is set to 2 by default. So we usually tell users that if it's an indoor scene with a lot of like a lot of details, to put it to 2 to 3. But if it's a massive terrain and it's not a lot going on, you can crank it down to very low numbers. And then don't forget to generate your lighting. So it's actually just pre-computed this indirect light that I was talking about. And then we have baked global illumination. Oh, that's really bright. So this is probably what most people think of when they hear like baked lighting. So you just like bake everything down on a flat texture, then you then dress onto the object. So here you can see that shadow is static on the texture, so you're not going to be able to move it around afterwards. So for that you need to use the pre-computed real-time GI. And since we're dealing with light maps, we have a lot more settings here. And the first one you need to make, like the first decision you need to make is what light mapper you're going to use. So from 5.0 up until 5.5, we only had Enlighten for both real-time and baked GI. But now for baked GI, we also have the progressive that is made in-house by my team. And so what is progressive light mapper? First of all, it's a preview. I can't really, wait, I need to, okay, great. It's a preview, so not all the features of it is available currently, but everything, like, there's a few issues with it that we're gonna backport to 5.6. So if you have 5.6, don't worry, it's gonna be feature complete, so to speak. And it gives you kind of a lot faster iterations than Enlighten. So as you can see in this demo here, as you're moving around with the camera, so we're only calculating the light maps that you're seeing first, and then we're doing the stuff behind you. So it means that you can zoom up on a problem area in your scene, and that bakes a lot quicker. And it's also very, much more robust than Enlighten, in the sense that in Enlighten we're dealing a lot with these systems and clusters, and it's so many different relationships. So if you're changing something at the end of the scene, you can get changes where you're at, and it might not make sense. So you can get artifacts where you're standing, for example. With Enlighten, we're actually calculating the pixels on that particular area. So, it's more what you see is what you get. But currently, it's only suitable for small to mid-sized projects, because we're allocating all the light maps. When we're baking, we're allocating them all in the beginning. So you will essentially run out of memory if you're dealing with thousands of light maps. But that's something we're working on, and it's going to be backported to 5.6. So don't worry, bear with us. Because, we know that it's for big projects, you kind of want the fast iterations. And for the settings, first of all, for this talk, I'm going to go with Enlighten, because that's, the thing most people are familiar with, and everyone haven't, upgraded to 5.6 yet. So, first of all, we're going to do the indirect resolution. So that's kind of the same as for real-time GI, because it's usually the same kind of pipeline, essentially. And then we usually tell the users to put the light map resolution to 10 times higher, just as a starting point. You can still, adjust that as you go, but it's just a good rule of thumb. And then these settings I'm going to speak about later in the UVs and artifacts section. And then before you can actually get any light maps, don't forget to set the mode on your light to baked before you actually bake. So you get, so you generate any light. And then you hit generate lighting. So to summarize, it's a very lot of information, but I'm just going to walk through every column one by one, essentially. So if you don't pick any of the not real-time GI or baked GI, you essentially going to end up with this one. So you don't have any indirect light, essentially. Everything else is real-time, and you can only have real-time lights. So if you have baked lights, they're just going to fall back on being real-time. And it's not using any light mapper. If you're doing pre-computed real-time GI, currently we're only having Enlighten for that. And so for the indirect light on static objects, it's going to be pre-computed, but we're not going to have anything on dynamic objects, so things that's not in a light map that isn't marked as static. And then if we have baked global animation, as you can see, it's only the static objects that will get any of the light, essentially. And here we have the progressive and Enlighten, and it works on the baked lights. And as you can see, there's a lot of gaps here, as I pointed out. So this brings us to mixed lighting. And this is essentially the problem we're trying to solve here. So this lovely scene here that I made, we have all the walls and the floor is light map static, and also the sphere. So that is getting that redness, the indirect light onto it. But then we have the blue sphere, which is dynamic, so it's gonna move around. As you can see, it doesn't have a shadow, and it doesn't have any of that redness onto it. So it's just really bright blue, and that's not gonna look great. And it kind of brings your mind to, these really old, like, Tom and Jerry shows where you kind of knew which object they were gonna pick up because it just wasn't drawn the same way as anything else, and it didn't have any shadows. So we really don't want that, especially not with today's computer power. So we have this mode. So it's not real time, it's not baked, it's something in between. And it also comes with 3 different modes now, as you can find in the Lightmaps settings panel. And hopefully this is not too much, but essentially what it is that the indirect light is always baked. And then the direct light and shadows is either real time, so if the baked indirect is the heaviest of them, so it requires the most like computer power, and then the subtractive is like the lowest quality, so it's more suitable for mobile, for example. So here, it's real time, but then if you look at subtractive, for example, we only have like 1 real-time shadow caster. So that's very suitable if you're doing like a massive train scene and you have like 1 sun. You don't really need anything else to cast shadows. So that's really good for that kind of stuff. So that solves the problem with the shadows. Then we have these things, the light probes. So what these essentially do is that you bake down the indirect light in the scene to these things, and they interpolate between them to kind of give this the indirect light on dynamic objects. There's a lot more here you can say about like bring up LODs and stuff like that, but I had to like call my team, and I'm not gonna. But you can use them for a lot of things. But so demo time. Hopefully, not even Nigella can pull up baking in real time. So, oh shit, I can't. Okay. So this is essentially the scene, and we have 1 dynamic object, and this is a static object. And currently, we only have 1 real-time light in the scene, as you can see here. So it's real-time, and the scene looks very, sharp. So if we go ahead and put this as baked, and then we go into Lightmap settings, and we turn on baked, and we generate some baking. So this is what you end up with. This doesn't look very nice. So it's only getting the light from the skybox, and it's not getting any of the shadows or anything. So we're gonna go ahead and make that the light mixed. And now we're using baked indirect, so that was the heaviest one, but that's fine for now. It's a small scene. And if he, Okay. So here we clearly can see that, I don't know if it's, so on the left sphere we have that redness that's bleeding onto it, but we can't really we don't have that on this one. But all the shadows and everything else is kind of correct. So we're gonna head and bring out our light probes. So I'm just gonna turn them on, and you kind of just, change them around like this. Really nice. And before you can actually use them, don't forget to bake down the lights in them, because otherwise they're not gonna know what's going on. And now, if we take this our dynamic object, if we're moving it around now, you can clearly see how which probes it's gonna interpolate between. So this is it's very handy. So if we just play now, we have baked lights, we have indirect light on this dynamic object, and we also have shadows. So this is, kind of what we want. So yeah, quick demo. So now when we have light probes and mixed lighting, we kind of start filling gaps in this table I was showing earlier. So for pre-computer real-time GI, you can use these light probes on dynamic objects, so that's going to fill that gap. So now this is kind of complete. And then for baked global illumination, we now have a new column, so for the mixed lights. So here you can see that it's real time or baked depending on what mode you're using. And also for the indirect light on dynamic objects, you're gonna use light probes essentially. So yeah, then you're good to go. UVs and artifacts. How many of you guys know what artifacts is? How many have had a problem with it? Okay, a few people. So what are UVs? This is essentially the coordinates on a texture. So when you're doing the UV mapping, you're mapping the UV coordinates on this 2D texture, and you're wrapping it on into 3D space, so X, Y, and Z. So UV is just, before that, very creative name. And artifacts. So these essentially are like things that shouldn't be there, like random shadows or light spots that when you look at it, you're like, I don't know what's going on, that should not be there. So now I'm going to show you how you kind of end up in this state and how you can solve it with a few suggestions. So for this demo, I was using Maya 2017, and I made this really nice box with a lot of edges. And first of all, you select it and you go in under UVs and you take the little square next to it, which gives you a lot more options. And if you scroll down, first of all, you need to make sure that the spacing presets is the same as your light map size. So if it's much bigger, that's not going to make any sense because it's not going to fit. So make sure that they are the same size or smaller. And then we end up with this pretty thing. So it's just that cube flattened out as, it looks nice. And here you can see this. So it's pretty much like a collection of these charts. So small islands of like the faces on the mesh. And then we're going to send this to Unity with this nice send to Unity option in Maya. It's really good. We also have Unreal if that's what you do. But you select the object and then you, do the selection thing. And this essentially gives you an FBX object that you can then drag into Unity. And I dragged it out in the scene. I marked it as static and I hit bake. And it looks like shit, basically. And I go in and I look at my light map and I'm like, I don't know what's going on here. Why does it look like this? And here you can see all the nice islands, so the UV charts. But if you zoom up on it, we can clearly see here that they're just way too close to each other. So the blackness or the whiteness is leaking over just because it's not, quantum physics. So you can't have a white pixel and a black pixel at the same time. And we need to kind of fix this. So the first option, if this is your own mesh and you have access to Maya, we can just go in on these settings again. And here we have like a spacing setting. And there's no magic number here, so it's just depending on your light map size and pixel density. But so just like try and get a number so you get like a good spacing essentially. But if you, like a lot of other people, download these assets from Asset Store, or you don't have, access to Maya, you can also go in on the import settings on the FBX object. And if you scroll down, we have this little thing where you can just generate lightmap UVs. And if you, under advanced, you're also gonna get the pack-in margin. And by default, that's set to 4, but I kind of had to crank it up to 17 or 19, just to get a good result. And when you hit apply, it's gonna look something like this, which is, don't panic. This is essentially, so we have the same light map, but the dressing instructions are completely off. So it's just putting its pans on its heads, basically. So all we need to do is do a rebake, and it's gonna look good. And if we look at the light map now, it's just a lot more space. And what you essentially want to have is 2 full texels between the charts. So even here you can see it's going over half a texel, but then you want another one after that, because the interpolation, how we do it, it always requires one extra next to it. So all these checker things are the texels. What if this fails? What should I do then? Try to increase it a bit more until you have this result. And you can also try and adjust the light map resolution. And one thing I realized when I was doing this, that if I untick the compressed light maps, I can get rid of some of you can get weird artifacts in corners, for example. So if you're doing a high-end PC game, just untick this one and see if it profiles well. And then we also have the light map padding, which is different from the chart padding. And this here we have a big light map, essentially. So all the the meshes charts or their light maps is in here. So here we have 2 objects, and sometimes they can be too close together. So if you have a big room and you have something at the very end of it, and that bleeds over to your object, it might not make sense in this space, but on the light map it makes perfect sense because they're just too close together. So try and adjust the actual light map padding between these 2. And here you can also see that, so the light map size specifies the height and the width of the light map. What about real-time UVs? Has anyone done anything with real-time UVs before? Does anyone know what it is? Okay. Essentially this thing. So here, it's a bit different. We have a much lower resolution, and we have these funny colored charts where the UVs are placed inside. So you don't have to have one chart for one UV anymore. And this is very Enlightened specific. So this is used when you're doing pre-computer real-time GI. So we essentially take the colorful charts, and then we combine that with that relationship data that we have, and then also all the lights at that frame. And we render low resolution light maps for the indirect light in real time. So we kind of end up with this thing. And you can also debug them if you go to the object view in Lightmap settings. So this is the current snapshot of the scene with the placement of the light now. So yeah, it looks a bit different. And if you want to change these ones, you can go in on the scene mode, and you can select UV charts, and you get these nice bouncy house look on your scene. And here you have 2 options. Either by default, you optimize your real-time UVs, and essentially you're giving the problem to us. So we're doing a plane projection on everything, and you have a few settings for it. Or if you want to do the job yourself, and you think you have really nice these islands that I was talking about, you just untick this one, so you preserve the baked UVs that I was showing earlier, but we just pack them differently. So if it doesn't look exactly the same as your baked light map, don't worry, it just we just fix it up a little bit, so you don't need that extra padding anymore. But keep in mind that this is, yeah, as I said, real-time or Enlighten specific. So it actually affects both the baked and the real-time GI, because it's part of the same pipeline. So yeah, it's the baking time and the real-time calculation. So if you're having like spikes, or if the baking takes a lot longer than you were assuming, have a look at these charts. So you kind of want to reduce the number of charts without adding distortion. And what do I mean by that? So this is kind of like a standard scene. You have a lot of tiles here on the floor, and this is the charting for it. And it's just, a bit too much, because all these tiles, they kind of, they have the same kind of indirect line. So we don't really need to have these many charts, and it's just going to spike up the baking time or the compute time, because we need to go over every single of these things and calculate the relationship and the lights, everything during runtime. So it's going to be very heavy. So what instead can do is, if we do the optimization, so we do the plane prediction I was talking about, then we realize that the floor, all of them can just like be put in the same chart, essentially. So this, the resolution of this is much, much lower, and it's just gonna, fly off faster. This brings me to the last subject. So we brought up a few, tips to speed up the bake with, changing the charts. But now I'm gonna give you 2 tips that a lot of users have issues with. So light probes, very friendly little things that you should use. So I downloaded this really, really nice scene. It's called Evgena. So it's a dinner table assets from the asset store. And everything was kind of marked as static. So I did a bake, and it took 3.5 minutes. And then I was like, okay, how can I actually speed this up? So I looked at the chicken, and we had all these like teeny tiny objects that, they don't really, we're not need to include them in the light maps, because they're not going to do that much to the indirect light. They're not going to bleed their color onto the chicken that much, and no one's not really going to notice. So I kind of unticked them. So you can untick the light map static on them. So you just make them dynamic from a light map point of view. And I kind of set it up like this. So I just like shatter a few probes on the table, marked all the tiny objects so I don't like pollute my light maps. And I got the baking time down to 20 seconds, essentially. So this can do a lot. So we've seen a lot of people coming in with scenes where they marked every rock on a big surface as static, because they want, to have that, fast game. But that's just going to slow down the baking time. Or if they're using real-time GI, that's going to, it's going to be very expensive, essentially. So do this. And progressive light mapper, that's also very, very good, because compared to Enlighten, where you can change the light map resolution, for example, to speed up your bake if you're doing fast iterations. But then when you crank that up, you might get completely different result. You have artifacts that you maybe didn't have before, for example. But with progressive, you can just pull down the direct and indirect samples. So that's essentially rays in this light mapper. So drag them down. The image is not gonna, it's not gonna look pretty, but you can see where the shadows are and where the light, it's the problem areas. And then at the end of the bake, you can just crank it up, leave work for the day, and come home, come back the next morning, and it's hopefully done. So what's next? If you find this really interesting and you want to do more baking, I really suggest to go in on our documentation page. We're still working on a few things, but because a lot of things are changing with the light modes, for example. And then we have this, most of the things from today I took from, we have a guy called David at Unity who wrote this really, really nice tutorial on how to speed up like a real-time GI. So I think he took a scene from like 7.5 hours down to 2-3 minutes baking time, which was insane. Um, and this is Enlighten specific, and it goes over all the light map parameters. And even though it's for real-time GI, if you're using baked Enlighten, that's, you know, they're sharing a lot of the same pipeline. So if you're speeding up your real-time GI, you're gonna get a lot of speed up on your baking time as well. So have a look through it, like it explains pretty much everything. It's really nice. And as for my friend, the guy that I was talking about earlier, who were struggling with his baking, he finally baked his light maps, and it's all good. You don't have to worry anymore. Thank you. Does anyone have any questions? First question.
Hi, I actually have two questions.
Okay.
One is, are there any specific rules of setting up light probes? Like I'm always doing it like in a grid,
Yeah.
but I think maybe if you do it like more specific in corners or on areas where it's really important, you may do another setup of light probes and not just a regular grid.
Yeah, it can be a bit difficult. Like you need to keep, if you have walls, for example, you need to put them very closely together so you don't get that interpolation, so it bleeds over from one room to another, for example. So that you need to pay attention to. But you know, like I haven't done it that much myself. But one thing I'm actually gonna redo how we edit the light probes later on this year. So if you have any, you know, like if you're struggling with light probes, like we have a few issues with them. They're not very, it's very hard to like do a massive scene, for example, because you need to like hand change every of them. So we kind of want to do like a massive box, for example, and just like fill it up with light probes. So yeah, but no, I don't have any like direct advice on that. But if you have any tips for us how you would like it to be, come and talk to me later. Okay.
I mean, I'm good with my grids at the moment,
Yeah.
but maybe it can be better. So that was the question.
Yeah,
one.
no, we have we actually have a few technical artists. I think they would be much better. So I only do like the coding side of the light probes, not.
Okay.
So
and
yeah.
second question was, could you maybe explain some of those views I have in the scene, like these UV charts and texture density and stuff like this? Maybe just give us a few words about these views.
Yeah, this has actually been I'm actually redoing this at the moment because we had a few issues with it. So this is my build, so it doesn't look like this. So, first of all, we have these settings, and this is mainly for Enlighten. So you have the systems and the clustering. So that's, you know, if you really want to get deep down with Enlighten, this is the things that you want to look at. And so you can like, oh, god damn it. It's not perfect. Okay. So yeah, you have this mode. And you also have like this really nice, the light overlap, for example. So if you're doing a lot of mixed lights, for example, we only support 4 overlapping ones. So this one you can use to like point out the problem areas, for example. And then you can look at your baked light maps. So essentially just taking the light maps and just slapping them on the object so you can see what's going on. And you have albedo and emissive. So all the emissive objects that emits lights. So yeah, if you haven't played around with these different scene modes, I really suggest that you do, because it's just very helpful. And yeah.
You showed an example where you had the floor with a lot of tiles, and then you talked about reducing the number of UV things. Could you show how it's done? Because I have no idea.
That's actually the optimized UVs, and here you have a few settings, so you can change like where it's cutting off, for example. So this is on by default, so usually it works on like planes and stuff like that, but if you have like complex objects, you might want to untick this one. So that kind of doing like the plane projection and sees that all of these should essentially have the same indirect line.
That image is unchecked?
Oh no, I mean, sorry, this one.
Okay.
So this is the optimized version.
Okay. Another quick question.
Yeah.
Light leaks. Is that the same thing, the UV artifacts you showed us?
No. Yeah, that's a bigger topic.
Okay.
And yeah, I can. If you have any more like specific scenes or something, we can help you out in the expert.
Okay. Cool.
Yeah.
Thanks.
Hi, I have 2 more questions. So first of all, that chart you're showing there, is it needed if you're only using baked light?
If you're using Enlighten, it's actually Enlighten is a real-time GI engine originally, so we're using a lot of the same pipeline. So if you're having a slow bake, these might be the issue. So they're used for both baked and real-time with Enlighten. But if you're using progressive, you don't have to care about these at all.
All right.
Yeah.
And second question, those different views we're just talking about.
Yeah.
Is there a way to add own views?
No. Maybe talk to me. I'm adding a few ones now.
Thank you.
Hi, thanks. Very interesting talk.
Yeah.
I have a question about the progressive light mapper. I might have missed it, but is that something you would typically use for development stages, or is that something you would, eventually end up with using in your game? I'm quite confused about that.
I would suggest to use it at the beginning so you can interact much faster. And especially if you're doing like a small project, start out with it and see, it's the same as Enlighten essentially, just that it doesn't work on really, really big scenes.
Okay,
Yeah.
so let's see, that means that once you're like developing a scene, you use progressive, so then you have to switch back to non-progressive, I guess, and then
Yeah,
make
if
a build
we
and
haven't
test.
fixed the problem by then.
Okay.
Hopefully, we're gonna backport it. The guys are working very hard in it, so yeah.
Okay.
But
thanks.
at this point in time, that's the only thing that we haven't backported yet to 5.6.
Okay, thank you.